Good morning, viewers. This is Kasturi Day. Today I've come again with the chapter. This is measurement and just a minute. Measurement and experimentation chapter of ICSE syllabus class 9. Okay. So in my last video, this is a physics chapter. Okay, the first physics chapter which I'm discussing in this class. So in my last video, I discussed about the units, then the examples of the units, what are the kinds of unit, how to choose a unit, what are the systems of unit, prefixes, and then units of length. Now, I am today will be starting with unit of mass. Okay, so what is the unit of mass? The SI unit of mass is kilogram. The SI unit is followed, SI system is followed nowadays. Okay, so this SI system of mass is kilogram. It's written in small kgs, small letters in lowercase kg. So it is the mass of 1 liter of water at 4 degrees centigrade. Mass of 1 liter of water at 4 degrees centigrade is considered a standard, and that is considered the measurement magnitude of kilogram. So 1 kilogram is equal to mass of 1 liter of water at 4 degrees centigrade. This definition was given by in 1889. Okay, first it was defined in 1889. Now, the definition of this kilogram is it is the mass of a cylinder piece of platinum iridium alloy. It's a rod which is made up of platinum iridium alloy. Both the metals are there, making it an alloy, making it a cylinder piece, and the cylinder piece is weighed. The mass of that cylinder piece is kept at International Bureau of, the cylinder piece is kept at International Bureau of Weights and Measures at Service near Paris. The mass of that cylinder piece is termed as 1 kilogram. Okay. Now, according to 20th May 2019, this kilogram, it is defined as the terms of fundamental value, which is known as Planck's constant. Okay. It is known as 6.62607015 into 10 to the power minus 34 kg per meter, kg meter square per second. Okay, that is the Planck's constant, and it is defined as the term of fundamental value. It's the term of fundamental value, which is known as Planck constant. Now, the Kibbles balance measures that the mass of an object using a precisely measured electromagnetic force and using Planck constant. Okay. Now, the subunits of kilograms are gram and milligram. So first, SI unit is kilogram, and the subunits of kilograms are grams and milligrams. These are smaller units than kilogram. Now, what is a gram? 1 gram is 1,000 part of a kilogram. So 1 gram is equal to 1 by 1,000 kgs, or you can say 10 to the power minus 3 kgs, or 1 kilogram is equal to 1,000 grams. Now, milligram is 1 millionth part of a kilogram, or 1,000 part of a gram. So 1 millionth means 10 to the power minus 6 part of kilogram, or 1,000 part of a gram means 10 to the power minus 3 grams of parts of a gram. So 1 milligram, 1 mg is equal to 10 to the power minus 6 kg, or 1 mg is equal to 10 to the power minus 3 grams g. Next is the multiple units of kilogram. So these are the previous one were the smaller units of kilogram, and that now we are coming to multiple units of kilogram, the bigger units more than kilogram. Okay, though that is quintal and metric ton. Okay, now quintal, what is quintal? Quintal is 100 times of kilogram. Okay, so kilogram multiplied by 100. So 1 quintal is equal to 100 kg. Okay, now metric ton is 1,000 times of a kilogram. That is 1 metric ton is equal to 1,000 kgs or 1 quintal. Okay. And it should be 10 quintals, I suppose. Yes. Okay. There's some mistake in that. Uh, uh, it's 1000 kg or 10 quintals it will be. Okay. Then non-metric tons, atomic mass unit and solar mass. Atomic mass unit is equal to, it is 1 to atomic mass unit can be written as AMU. It is the 1/12th mass of one carbon 12 atom. The carbon 12 atom, if it is made into 12 parts, 1/12th of the mass of the mass of carbon 12 atom is divided into 12 parts, and 1/12th of the mass of the carbon atom is equal to 1 atomic mass unit. Now, the mass of 6.02 into 10 to the power 26 atoms of carbon 12, carbon 12 is equal to 12 kgs. 1 AMU, or U you can write, small u is equal to 1 by 12 into 12 by 6.02 into 10 to the power 26 kgs, or you can say 1.66 into 10 to the power minus 27 kgs. Okay, this is used to measure the mass of electrons, protons, and neutrons, because these are very small substances and you cannot measure them in bigger masses, like bigger mass units like grams or kilograms or quintals or metric tons. These are very bigger units in comparison to the size of the substance. So mass of electron, protons, and neutrons, there is these electrons, protons, and neutrons, these are very smaller substances, and for that reason they are measured in atomic mass units. Now we come to solar mass. Okay, these are the non-metric units. Atomic mass unit, solar mass, these are all non-metric units. Okay, it is the mass of the sun. Solar mass is the mass of the sun. That is known as 1 solar mass is equal to 2 into 10 to the power 30 kgs. Okay, it is used to measure the mass of large heavenly bodies. 1 atomic mass unit is used to measure very small substances, and solar mass is used to measure it is used to measure very large substances, very large bodies, like the mass of the heavenly bodies. Okay, now next we come to unit of time. Now, unit of time is, SI unit is second. Okay, seconds, and it's written as small s. What is that? It is 1 by 86400 part. That is 1 by 86,400th part of a mean solar day, or 1 second is equal to 1 by 86400 into 1 mean solar day. Now, what is 1 solar day? It is the time taken by the Earth to complete one rotation on its own axis. Okay, so it is the time taken by the Earth to complete one rotation on its axis, that is 24 hours. Okay, the one rotation of the Earth on its axis is 24 hours, we know. So that is 1 solar day, and multiplied with it 1 by 86400 gives the time, unit of time, that is second. 1 second is this much. Since the variation of the value of mean solar day over the years, scientists started to consider 1 year, that is 1900, into and 12 years as ephemeris time. And 1 year 1900 is equal to 365.2422 days. Okay, 1 year is equal to, now it is 365.2422 days. Okay, it was first started from the year 1956. First started was in 1956. 1 year 1900 is equal to 364.2422 days, which is equal to 36.4 days, means it is converted into seconds. What is second? It is 86400 seconds, and that makes the days, it is converted to 8644 seconds. That means you can say days into 24 days. I mean, 1 day. Okay, 1 solar day. 1 solar day is uh, 24 days. 24. So that 24 is converted into, again, broken up into this one time, and this one hours, and then minutes, and then second. That gives to 86400 seconds. So total second is 31556,926.08 seconds. So 1 second becomes 1 by 3156926.08 part of the year 1900. 1900 year is taken as standard. So 1900, as the scientists started this in 1956, so they took 1900 year as the standard year. Okay, and 1 year of that year calculation is taken as 365.2422 days. Okay, in 1964, 1 second was defined in the terms of energy change. Okay, that is 1 second is the time interval of 9,192,631,770 vibrations of radiations corresponding to the transition between two hyperfine levels of the ground state of cesium-133 atom. So 1 second is the time interval of the vibrations. Of what vibrations? This time, this amount of vibrations, 9,192,631,770 vibrations. Now, this number of vibrations of the radiations. Whose vibrations? The radiations which are corresponding to the transition. When these vibrations are forming, when there are radiations, of what radiations? When these radiations are coming, when there is a transition between two hyperfine levels of the ground state of the cesium-133 atom. When ground state of cesium-133 atom, two hyperfine levels are transforming one state to another. That time some radiations are coming out, and these radiations are creating some vibrations. These number of vibrations, that so much of vibrations are coming out, and the time interval of these vibrations is known as 1 second. Understood? Okay, next we come to units of time, the smaller units of time: millisecond, microsecond, shake, and nanosecond. 1 millisecond is equal to 10 to the power minus 3 seconds. 1 microsecond is 10 to the power minus 6 seconds. 1 shake is 10 to the power minus 8 seconds, and 1 nanosecond is 10 to the power minus 9 seconds. Okay, now bigger units of time are minutes, hour, day, lunar month, year, leap year, decade, century, and millennium. First, we come to minute. 1 minute is the duration of 60 seconds. That is 1 minute is equal to 60 seconds. Hour, 1 hour is the duration of 60 minutes. So 1 hour is 1 hour is equal to 60 minutes, or you can say 60 into 60 seconds, or 3600 seconds. Now day, 1 day is the time taken by the earth to rotate once on its own axis. That is 1 solar day, you can say, or it is 24 hours. So 1 day is equal to 24 hours, or you can say 24 into 60 minutes, that is 1450 minutes, or you can say 24 into 60 into 60 seconds, or we can say 86400 seconds. Now, lunar month, it is the time period of revolution of the moon around the earth. Time period of the revolution of the moon around the earth, or the rotation of the moon about its own axis. One is, it's the same thing. Revolution of the moon around the earth and rotation of the moon about its axis is both are the same thing, and the time period of that is known as lunar month. So 1 lunar month is equal to 27.3 days. 10 year, you can say 1 decade. 100 years is 10 decades or 1 century. 100 years, 1000 years is 10 centuries or 1 millennium. Okay, next is, we are coming to 1 lunar month. According to Hindu and Muslim calendars, 29.5 days. Okay, according to Muslim, Hindu and Muslim calendars, one lunar month is equal to 29.5 days and 12 lunar months is equal to 354.37 days. And 1 month according to Gregorian calendar, it is 30 days approx, as January, March, May, July, August, October and December, they have 31 days, and April, June, September, November, they have 30 days. But and February has 28 days. So average, on the average, according to the Gregorian calendar, 1 month is equal to 30 days and 1 lunar month is equal to 29.5 days, or 12 lunar months is equal to 354.37 days. Then 1 year, it is the time taken in which the earth completes one revolution around the sun. Okay, we have studied in the lower classes also that 1 year is equal to the total, the one revolution of the earth around the sun. So the period of revolution is 365.256 days, or you can say 365 days approximately. So 1 year is equal to 365 days, or you can say 365 into 864400 seconds. So that means 3.1536 into 10 to the power 7 seconds. Now, one leap year is the year in which the month of February has 29 days, and also a leap year has 366 days because one day has increased in February. It is usually the year which is divisible by 4, like 1964, 1968, 1972. These are divisible by 4. So these years are leap years. Otherwise, 365 days cannot be divided by 4. So other years are not divisible by 4. And those years which are not divisible by 4, they are not the leap years. Now, decade means it's 10 years. 1 decade is equal to 10 years, or you can say 3.1536 into 10 to the power 8 seconds. Okay. Then century, it's 100 years. In a century, there are 24 years of 366 days each, and 76 years have 365 days each. Okay, so in this 100 years in a century, there are 24 years of 366 days and 76 years have 365 days. So 1 century means 100 years, and that means 24 into 366 and 76 into 365. That means 3 days. These are all days. We are converting years to days. Now that makes that 36524 days, which means 3.16 into 10 to the power 9 seconds. In a millennium, there are 1,000 years, and 1 millennium is equal to 3.16 into 10 to the power 10 seconds. Okay. Next is some derived units. See, area we have, these are the fundamental units which we have studied: length, mass, time. Now we come to some derived units like area, where two fundamental units are combined together, forming a in relation with each other to form a derived unit. See, area, there is length, which is combining length again, combining with other lengths to form area. So fundamental units are used here. Okay. Then the unit is meter square. The symbol is m square. Then volume also 3 times the length is multiplied. So this also is a derived unit, and its symbol is m cube or cubic meter. Frequency is 1 by period, 1 by time period. So time is considered here. Okay. So this is time is a fundamental unit. So its unit is hertz, and Hz is the symbol, or you can say per second. The density is mass by volume. Mass is a fundamental unit, and volume means the fundamental. Volume is a derived unit, which is a combination of this fundamental units. Okay. So its unit is kilogram per cubic meter, or you can say kg per meter cube. Next, velocity is displacement by time. Displacement is a fundamental unit because it has length in it, and time is a fundamental unit. So it's this one unit will be meter per second, like it can be written as m s to the power -1. Acceleration is velocity change by time. Velocity is a derived unit, which means displacement by time. So, and time is a fundamental unit. Okay. So meter per second squared, or you can say meter per s to the power minus 2. Force is mass into acceleration. Now mass is a fundamental unit and acceleration is a derived unit which contains velocity by time. And again, velocity is equal to displacement by time. So acceleration is a combination of fundamental units, and therefore the unit is Newton, and it's written as capital N, or you can say M as mass kg per second square. Okay, sorry, M kg per second square, not mass, it's meter kg per second square. Then pressure, stress. Pressure is pressure or stress, the same formula, that is force by area. Force is mass into acceleration. Again, there is a combination of fundamental units. Area is itself a derived unit, which is a combination of fundamental units. Its unit is Pascal, PA, it's written, or you can say Newton per meter square. Then energy, work is equal to force into displacement. Energy also force into displacement. Then its unit is joule. It's written as capital J, Newton meter. Or you can say Newton meter. Then power is work by time. Work is force into displacement. So the unit is watt, and W is a symbol, or you can say joule per second. Quantity of electricity, quantity of charge is equal to current into time. Okay, current, it's this one, it is Coulomb. Okay, C is the symbol, or you can say AS. Then potential difference, electromotive force, it's energy by charge. Okay, it's volt, or you can say W to the W by A. Okay, watt per ampere. Then electric, this one, electric resistance. So resistance equal to potential difference by current, that's ohm. Okay, then that is, it is written in this way, and this is the symbol of ohm, and it's velocity by volt by ampere. Okay. Next will be the guidelines for the units, for writing the units, how to write the units, okay, of the magnitude which we have measured, how to write the units. The symbol of the unit which is not named after a scientist. Okay, the symbol of the unit which is not named after a scientist, they are written in small letters. For example, meter is written as small m, second, it is written as small s, kilogram, kg, small kg. Okay. Then if the symbol of a unit is named after a scientist, then what happens? It is written as N for Newton, capital N for Newton, J for joule, W for watt, Pascal, capital P, small a, Pascal, Hertz, HZ for Hertz, then C, Coulomb, okay, V for volt. All these things are written, right? Then these are named after the scientists. Now, some exceptions are there. The units of volume, that is liter, is sometimes written as capital L instead of small l. Why it is so? Even though it is not named after a scientist, then also it is written in capital L. This is to avoid the confusion between small l and I's, capital I. Okay, so to avoid this confusion, capital L is written for volume, representing in liters. Okay, then the full name of the unit, whether it is named after a scientist or not, okay, its initial letter is written in the lowercase. For example, unit of mass, kilogram, and not kilogram. It is written in small kilo, K, okay, kilogram, and not in capital K in kilogram. Unit of force, Newton, is not when you are writing the total name of it, not the symbol, but the total name. When you are writing the total name, you don't write the unit of force as capital, starting with capital letter or uppercase letter Newton, you need to write in small lowercase letter, that is Newton. A compound unit, multiplication of 2 or more units is written after putting a dot or a cross or leaving a space between the two symbols. For example, unit of torque, it is Newton meter. So Newton dot meter, or you can say Newton cross meter or Nm, like this. Okay. For compound units, negative power is used, formed by dividing one unit by the other. Okay. For compound units, unit of velocity, meter per second. Okay. Like when it is written meter per second, you express it as m, s, m, a little gap, s to the power -1. Okay. Next is certain other guidelines for writing the units. A unit cannot be written in plurals if it is expressed in short form. When you are writing in the short form, like ms, millisecond. Okay, you cannot write meters as ms because ms stand for millisecond. If you write meters, that will become ms, but that is wrong. You need to write as m. 10 meters means 10 m, not 10 ms. Okay. Preferable, a prefix can be written with a unit to avoid the powers of 10 in the magnitude of quantity, but more than one prefix cannot be written. We cannot write kmw. We need to write gw. Okay. If a prefix is written with the symbol of unit, the prefix and the symbol becomes a new symbol of the unit, like km cube. That means 10 to the power, k means 1000. So 10 to the power 3 meter total cube. That means 10 to the power 9 meter cube and not 10 to the power cube, 10 cube meter cube. This is wrong. Okay. So this much is for today. Go through the video. If you have any doubt, do write in that comment box. Do share with your friends so that they can also be benefited from these videos, and press the like button. And also, the last and not the least, please do subscribe to get the notification of my next video. Okay. And as I told you, I'll be discussing ICSE question patterns with you all. So you need to stay with me for this reason, and you need to subscribe my channel. Okay. And one more thing, I will tell you that before sitting to study, you please meditate to increase your concentration. Okay. Thank you. Thank you for watching, and have a good day.